Okay, let's look at example 8.56, which says, at one instant, the center of mass of a system of two particles is located on the x-axis at x equals 2 meters and has a velocity of 5 meters per second I hat. One of the particles is at the origin, the other particle of mass 0.1 kilograms is at rest on the x-axis at x equals 8 meters. Okay, so we have, whoops, this should say M2. So I have M2 located out here, having 0.1 kilograms at x2, we'll call it 8 meters. M1 is located at the origin, and the center of mass is located at 2 meters and is moving at positive 5 meters per second. So because the center of mass is closer to M1, we know M1 has to be larger. Since V2 is at 0, meaning M2 is at rest, but the center of mass is moving, that means that M1 must also be moving in that same direction. Okay, so now that we have that set up, part A wants to know what is the mass of the particle at the origin. So I'm going to try and find M1. Now, given the information I'm given, I know the center of mass and I know the location of both masses. So I'm going to use my center of mass equation. So XCM is going to be M1 V, oops, close there, M1 x1 plus M2 x2, all divided by M1 plus M2. Now M1, you'll note, is located at the origin, so that is 0. And so I'm just going to have to solve for M1. So I'm going to multiply this term over here and divide the XCM over. So I have M1 plus M2 equals M2 x2 divided by XCM, and then subtract the M2 over. So M1 is going to be 0.1 times 8 divided by 2 XCM minus 0.1. And so I find out the mass at the origin is 0.3 kilograms. Okay, fair enough. Makes sense, it is larger. Another thing to note is that this is 0.3 and the other one is 0.1, so it's 3 times as massive. That means that if I think about the ratio of the distances, I see that if this is a 3, this is a 1. There's a 3-to-1 ratio in the distances, just the same as there's a 3-to-1 ratio in the masses the other direction. Okay, part B. Part B says, calculate the total momentum of the system. So when I try to find total momentum of a system, there's 2 ways for me to do it. I can either find the total mass and multiply it by the velocity of the center mass, or I can add up the individual momentums of all of the particles in there. Since I know VCM, and now I know M1 and M2 combined, I can go ahead and use this portion of my equation to find the total momentum. So the total momentum is going to be my 0.1 plus my 0.3 to get the total mass times my 5 I hat. So I get 0.4 times 5, so my total momentum is going to be, well, I should have done that in my head, 2 kilogram meter per second I hat, and it's in the positive I hat direction. Part C wants to know, what is the velocity of the particle at the origin? Okay, so now I want to find V1. I already know V2. Well, if I know the total momentum, can I find V1? Yes, so let's go ahead and do that. So I have the total momentum is equal to M1 V1 plus M2 V2. V2 was 0 because the object was at rest, so I take the total momentum 2 divided by M1, I get 0.3, and so I get V1 is going to be 6.67 meters per second I hat. All right, there is our example. Now, center of mass and momentum, because there's these 3 things equal to each other, I can kind of come at it from different directions. So solving these problems is a little bit more of a puzzle sometimes because there's a lot of information given. There's a lot we can do with these 2 equations as well. So stick with it if you get stuck.